I was asked in the comments to sort of do a breakdown of the graph or show the graph how I've sort of created this scene. These are all the flower heads are instances where they're an Alembic cache where the animation is triggered by the proximity of this sphere. So they all close when the sphere is near, and then they open up again when it moves away. So I was also asked about getting the shader to work, and how if I had got a shader to work with the Alembics in the instancing world of Bifrost. I haven't here. These are just a single variant of a yellow colour with red in the subsurface scattering, but I have managed to sort of get baked in vertex information into the instances, which I'll sort of show. So in Maya, this is the scene. So these are basically flower heads sitting on a floor. This is the mesh I'm using to instance. This is just a static mesh with no animation on it. I get this sort of weird viewport error when I'm using the Lambert shader and everything, so that doesn't actually exist. It's just some sort of weird glitch. The same with these sort of disappearing. They are there, they just go black for some reason. But that only happens when you've got the Lambert shader on. So if I just put the material on that's supposed to be on it, that one, they'll all go dark, so they don't show up in the viewport, unfortunately, but that weird thing's disappeared. So I'll just hide this guy because I don't need him. So this is a static mesh that I'm bringing in. Let's have a look at the scene, or the graph. So I've got two graphs, you can see there, that one. Let's just unhide that one for the time being, and let's hide that one. So you can sort of see there I've got, there we go, these are all the scattered points. So in the second graph here, this graph 2, I'm just scattering some points on a plane. I'm doing it in a different graph because if you do it in this graph and then feed the points into the other one, this doesn't get updated apart from on the first frame, and it sort of speeds up the whole scene. So piping those out points into an output, and I'm bringing them back in here. Let's just do that and try not to do that thing. So that's the endpoints coming in, and what I'm doing is I've got this platonic shape is the sphere. So I'm getting the point positions from my points, and I'm getting the closest locations from those points to the surface of this geometry. So I'm finding the closest points on this geometry from these positions. I'm then sampling those from this mesh. So I'm getting the points positions on this mesh here. So this is a point position sample. So this is finding all the points on this mesh that are closest to the points on the scattered instant points, with a cutoff distance, which at the moment is set to 5. I'm then subtracting the original points from these point positions, and by doing that I'm basically getting the distance between the two positions, which I'm then making into a length, which then gives me the actual length of those positions, or that difference between them. So basically it's the length of the vector between the positions on the mesh and the position on the point. I'm then going ahead and changing the range. So what I want to do here is change these lengths, which are generally should be somewhere between 0 and 5, because my cutoff is at 5. So I've got the value going in. I'm saying my start is 0, my end is going to be my cutoff range here, which I'm piping in, and then I'm converting that to a 0 to 19, which is basically the different frames of the animation. So there's 20 frames of the animation. I'm then putting that through an F-curve. You don't necessarily need to do this, but it gives you a little bit more tweaky control. Right, unhide all those, and we go in here. So I've got an F-curve, which I'm not really doing anything with at the moment, so it's sort of not tweaking anything, but it runs from 0 to 19, and goes in value up to 19. So basically it's a sort of stepped for the length of the animation, and this sort of new range, which is 0 to 19. If I play around with that, you'll see they slightly change there. Same if I do that, you see you're sort of playing around with the fall off. You don't necessarily need it, but it gives you a little bit of extra tweaking. Then I'm converting that from a float. Let's just do that so we can see the things at the bottom. I'm converting that from a float to a long, because the instant ID override, which is what these are going to become, wants an array of longs to go in. And then just before that, I'm just doing an if statement and saying if these locations are found, i.e. if the points are being sampled here and they are true, as in they fall within the cutoff, then do this true case. If not, do the false, which is 18. For some reason it's 18, not 19, but when I do 19 they all close like that, whereas 18 they all stay open, which is what I want. And that's, if you don't do that, you get a sort of weird, if I just plug that straight in, to there, you can see they all close up and you get some weird stuff going on where some are open. These are now open but closed. They sort of open up and close. So it doesn't know what to do with the ones that aren't within the cutoff range. So this is just saying if they're not in the cutoff range, just make them go to 18, which is sort of the last frame in the animation, it seems to be. So there, when you do that, they all sort of behave as they should do. So that's how I'm getting the sort of different instances IDs based on the distance between the point and the sphere. Then what I'm doing is I was doing two things. Well, the first time I did it, I was just basically extracting the, I've got it up here actually, in here I was just basically inside of for each, I was basically using the current index, converting that to be a frame number, and I had initial iterations of, let's go back here, 20, so that's the length of the animation. So it was going through it 20 times, and each time it was getting a different frame number, and it was just pulling that out and basically making, rather than a single mesh, it was making an array of meshes at each different frame in that animation. I've changed that slightly now because I've realized that when you bring in Alembic caches directly into the graph, it seems to lose some of the data. I think you're getting more data when you bring in them from Maya, like some of the sort of vertex face normal indexes and things like that aren't there. So what I was trying to do, and also you don't get any shader information, all that sort of, if you've got a shader on an object in Maya and you bring it in, the instances acknowledge that, and then you can carry that shader information on. When you do it purely in here, you don't get that. And I spent some time trying to sort of trick it into doing that, and then I realised that actually I was sort of thinking about it the wrong way around. Really all I care about in that Alembic cache of the animation is the point positions. So what I'm now doing is I've got a for each node here, same as before, but rather than just pulling out the objects, I'm actually just pulling out an array of point positions for each frame. And then I'm flattening that because you get an array of arrays, I think. Is it an array of arrays? Yeah. So I'm flattening that, and then I'm going into another for each node where I've brought in the static mesh with the shader attributes all intact into it, and I'm taking the point positions from the array I've got here from this one. So this array of point positions I'm bringing in, and then for basically every every iteration of the for each. It's going in, I'm changing the point positions of the intact mesh with the shader on it, and then I'm outputting an array of meshes, which then have all the point positions from the animation, but also store and keep all the shader information from Maya. So then I'm plonking that into the instances. I've got some random rotation and scale going in there from the points, and then finally I'm just making some random colours on the points and setting a new property called rand colour, which I'm actually just plugging into the subsurface scattering colour, which is then giving me, if I go open render view and hit that, so I'm keeping the baked in vertex colour that I've got in the original single mesh that's in Maya, and I'm also plugging in some random colour that goes into the subsurface scattering, so you're getting sort of randomised versions of these flowers. So just to sort of just clarify that one more time, I've got, if I put the Lambert back on you, so I've got a mesh in here with baked in vertex colours from that have multiple objects in it. As you can see, we've got colour there and different colours there, and petal colour. This is combined into one mesh, baked in vertex colours by doing, I did a pre-light there, so that just basically transfers the diffuse colours of the shaders into the vertexes. I've then got a shader on that, actually not at the moment, it's got a Lambert on it. If I go back here, so we see the shader, that will all go dark. So I'm just doing the standard AI user data color in there, set the color, which is the name of the color set, and then in Bifrost bringing that in here. But then I'm got this Alembic cache which holds the animation in it but doesn't hold any shader information. Pulling out the point positions out of that, going into a for each, getting the standard sort of static mesh and just applying the point positions at each frame to that, and then outputting an array of meshes, and that's what feeds into the instant geometry. Hope that helps.